Hey guys, it's Miss Johnson and I'm here today to bring you our first notes video for Unit 4. Today we're talking about how we find a greatest common factor. Now greatest common factor is probably something we've heard of before, but today we're going to be talking about how we look at the greatest common factor and take it out of a polynomial instead of just a number. So, let's just take a review, do a little review and talk about multiplying polynomials together. So if I'm multiplying a monomial by a polynomial, which is what we did in Unit 3, I distribute these all the way across and I multiply. 3 times 3 gives me 12. X squared times x squared gives me x to the fourth. Then 3 times negative 3 gives me negative 9, and x squared times x gives me x to the third. 3 times 2 gives me 6, and then I have x squared with no more x's. Okay, so what happened here is I took this factor of 3x squared and I applied it to everything in the polynomial behind it, and this was the product that I got out. So when I do this with 4x to the third, I have 4x to the third times 3x squared, and then times negative 2x, and then times negative 1. So 4x to the third times 3x squared is going to be 12x to the fifth. 4x to the third times negative 2x is negative 8x to the fourth. And 4x to the third times negative 1 is negative 4x to the third. So again, I took that factor of 4x to the third and applied it to everything in the polynomial behind it. Now, we're moving into a unit that we call factoring. And what factoring is undoing multiplication. So the first type of factoring that we're going to learn is how we find a GCF. So finding a GCF means that I am going to look for the GCF, which is the largest factor that can be taken out or divided out of each term. So the GCF is the largest factor that can be divided out of each term. A term can only be factored out if it is in each term of the polynomial. So a GCF, that C in the middle, stands for common. The term that you divide out has to be common among everything that is in the polynomial. So let's talk about how we find the greatest common factor. The first thing that we're going to do is we're going to find the largest number that factors into each coefficient. We're going to find the largest number of each variable that you can pull out. So this isn't just about numbers anymore. Now this is about variables as well. Then we're going to divide every term that we have by that GCF. So these two things make your GCF. The largest number and the largest variable, largest number of each variable. And then we rewrite the new polynomial with multiplied by the GCF. That's just going to be out front, like a coefficient would be. Okay, so factoring is undoing multiplication. It's kind of a weird concept to think about. Our answers to these questions are gonna look like they need to be multiplied back together. Okay, we're undoing this multiplication and seeing how it looked when we started it with that question. So that's what's happening here. Let's take a look at number 3. In number 3, I have 12a squared plus 16a. So I need to look for the largest common factor from 12 and 16. Well, 12 and 16 can both be divided by 4. So that's what I'm going to do. I'm going to divide both by 4. Then I also need to look for the largest number of each variable that I can take out. Well, my only variable is a. Here I have 2 a's, there I have 1. So the largest that they have in common is just a to the first. So I'm going to divide both of these by a to the first, meaning I'm taking that a to the first factor out. And what that does is give me a 4a to the first out front. 12 divided by 4 is 3. A squared divided by a to the first is a to the first. And then 16 divided by 4 is 4. And a to the first divided by a to the first cancels out. So what we have here is 4a times 3a plus 4. That is our factored form. Factored form is the undoing of the multiplication. That's your answer. So let's take a look at number 4. In number 4, I have 14r to the third plus 6r squared minus 4r. So again, the first thing that I want to look at are the numbers. 14, 6, and 4 have a common factor of 2. So I'm going to divide all these by 2. And then when I look at the variables, I have r to the third, r squared, and r to the first. And so the largest that I can take out is just r to the first. So that 2r is going to come out front. That's the GCF, by the way. That's my GCF that I'm taking out. Over here, the 4a was the GCF. Okay. So then what's left behind it is 14 divided by 2, which is 7. R to the third divided by r is r squared. If I have 3 r's on top, I get rid of 1 on the bottom. That's r squared. Then the 6r squared over 2r, 6 divided by 2 is 3. R squared over r is r. Then 4 divided by 2 is 2, and r divided by r cancels out. So this is my factored form of the expression. Let's flip it over and take a look at the back. In number 5, I have 5x plus 30y. So I'd start with the numbers. If I look at 5 and 30, I can divide both of those by 5. Then I look at the variables. This term has an x, but this term has a y. So I can't take out any of the variables because they don't have anything in common. Remember that GCF, the C stands for common. So I have to have something that's in common if I am going to take it out. So since I can't take out any variables, my only GCF, the only part of my GCF is just that 5. So then let's take a look at what's left behind it. 5x divided by 5, well, these go away and I'm left with just x. And then 30y divided by 5, 30 divided by 5 is 6. So I have a 6 and I have a y. That is my factored form. So then let's take a look at 6. In 6, I have 18cd squared plus 12c squared d plus 9cd. So if I look at the 18, 12, and 9, I notice that I can take out a 3 from all of those. So I know I'm going to divide each by 3. And then I have c, c squared, and c. So I can take out 1c from all of them. And then d squared, d, and d, I can take out 1d. So my GCF is 3CD. Again, that GCF is the thing you're pulling out front. So that was your GCF right there. Oops, GCF. So here my GCF is 3CD, GCF. You don't necessarily have to label that. I just want you to recognize that that's what I took out. So GCF is 3CD in this one. And then let's take a look at what's left. 18 divided by 3 is 6. C divided by C cancels. D squared over D is D. And then 12 divided by 3 is 4. C squared over C is C. And D over D cancels. And the last one, 9 divided by 3 is 3. C divided by C goes away. D divided by D goes away. One thing that you can do to check to make sure you pulled out the GCF is look at what's left inside. What's left inside better not have any common factors between each of the terms. So if I look at the 6, the 4, and the 3, there's nothing that I can take out of all 6 and 4 and 3 altogether. I can take out a 2 from 6 and 4, but I can't take 2 out from 3, so I don't have anything there. If I look at the variables, I don't have a D in all 3 of them, and I don't have a C in all 3 of them, so I know there's nothing left. So I know I got the greatest common factor out front. Let's take a look at 7. 12x squared 5y to the 5th minus 3x to the 4th y to the 3rd plus 9x to the 7th times y. So if I look at 12, 3, and 9, I have a GCF of 3. If I look at the x's, I have 2 there, 4 there, and 7 there. So I can actually take out 2 this time. And then if I look at the y's, y to the 5th, y to the 3rd, and y to the 1st, I can only take out 1 y. 1 y is my greatest that I have in common between all of them. So I pull that out front, 3x squared y, that's my GCF. And then I look at what's left. 12 divided by 3 is 4. X squared over x squared goes away. Y to the 5th over y is y to the 4th. Then 3 divided by 3 cancels. X to the 4th over x squared is x squared. Y to the 3rd over y, 3 minus 1 gives me 2. Notice by the way that I've been keeping my signs the same, I haven't taken out any of the negatives yet. So my negatives still say negative. Make sure you keep track of those. Then 9 divided by 3 in this last term is 3. And then x to the 7th over x squared is x to the 5th. And the y over y cancels out. That is my factored form. So again, it's kind of different because our factored form looks like we should take this and distribute it back in. But the art of factoring is undoing multiplication. So that's why when we factor something, it looks like it has these sets of parentheses in it. So now let's take a look at number 8. In number 8, I have 3x squared minus 2x plus 1. So 3x squared minus 2x plus 1, if I look at the numbers 3, 2, and 1, the only thing I can take out of all of those is a 1. Then I look at my variables, x squared, x, and no variable. I can't take any variables out. So my only GCF here is a 1. And when I divide by 1, nothing changes. So I still have 3x squared minus 2x plus 1. Now, that is an important concept for us to think about because 1 is actually a factor. This is a GCF, even though we often don't consider it a factor because dividing and multiplying by 1 doesn't change our answer. 1 is actually a factor, so consider that when you're thinking about GCFs in the future. In number 9, 15x squared y to the 2nd plus 25xy plus x. Now, a common mistake that people make with a question like this is thinking, oh, I can take out a 5. I've got 15 and 25. Well, you have to be very careful because the coefficient in front of x is 1. And 1 cannot be divided by 5. That does not work. Okay, not wholly anyways. So I can't take out any numbers here. The largest number that I can take out is a 1. So that's going to be part of my GCF is just a 1. And then if I look at the variables, I have x squared, y squared. Here I have xy, here I have an x. So I can take out 1x, but that's it. So I'm going to have a 1x out front. And that leaves me with 15x y squared, because x squared divided by x gives me 1x left over. X over x is going to cancel out. The 25 is still there, so plus 25. The x's are gone. I have a y. And then this last term, you actually have to represent this. So when I consider 1x divided by 1x, I get a 1. But I have to put that 1 there. It's like having a placeholder. If I don't put that 1 there, then I've dropped out that whole factor. And that's not what we want to do. So I have to represent that factor with a 1 because I actually took something out of it. So I have 1x out front, that's my GCF, and then the remaining 3 terms behind. So that's an important thing to remember too. I started with 3 terms. I better have 3 terms inside this polynomial in the parentheses when I'm finished, even if one of them is just a 1. So then let's take a look at number 10. In number 10, I have 4 terms, 8ax minus 6x minus 12a plus 9. So in this one, 8, 6, 12, and 9 don't have any common factors. 6, 12, and 9 have a 3. 8, 6, and 12 have a 2, but not all 4 of them have anything in common. So this is just a 1 that I'm dividing by. And then the variables, I have an a here and an a there, but not here and here, so I can't take an a out. I have an x there and an x there, but not in the last 2 terms, so I can't take an x out. So really my only GCF here is a 1. So if I take that 1 out, I'm left with the same thing. Now it seems kind of silly to rewrite the same polynomial behind, but I want you to understand that 1 is actually a common factor because we are going to use that in the future in this unit. Okay, so that takes us to the end of our notes for today. Thanks for listening, and don't forget to come get your practice from me and check off your notes, and I will see you all later.